number 45. Recall that f is a function of x, so there are only two variables, the input x values and the output, which are the y values, or the f of x values. So when we ask for f prime of x as a series, we're really asking for the derivative with respect to x, the derivative of f with respect to x, which means the n variables should just be thought of as constants. It's not as difficult as you might think. There's only one term here with an x in it. So taking the derivative of this term would be like taking the derivative of this expression. In the case when n was equal to 4, for that term, we would have had -1 to the 5th power, which is still -1, and then x minus 1 to the 5th power, x minus 3 to the 5th, and then 4 times 3 to the 4th. Or in other words, what's the derivative of that term? Notice there are no variables here. For each term, n is a constant. The only variable is x and f of x. And so we're taking the derivative of f with respect to x. You use the power rule. 5 times -1 3/24 is -5 3/24 times x minus 3 to the 4th power. That's the derivative of that term. And that's how we take the derivative to find the series for f prime of x. Using the power rule, n plus 1 multiplied by what's up front times x minus 3 to the power minus 1, and the bottom is just n times 3 to the n because it's just a constant. Doing the power rule again, n times the constant in front times x minus 3 to the power minus 1. And in this case, we have some things that cancel. So we would want to cancel n divided by n. And so this is the second derivatives series. So for the integral, we'll do the same thing. What's the antiderivative of this expression? It's like asking what's the antiderivative of? In the case of when n is 2, this is our term, so the antiderivative of that term. Using the power rule, the power will jump up by 1, and if you were taking the derivative, you would have the 4, so 4 divided by 4 cancels out, leaving us with just what we had. So just use the power rule. Everybody else is a constant except for the x. Here we go. The antiderivative of this term, where x minus 3 is raised to the n plus 1 power, is this expression. If we test it going backwards, the derivative of this would be n plus 2 quantity times this -1 times x minus 3 to the n plus 1. And that n plus 2 in the denominator would cancel out with this one, leaving us just with our denominator. You'll notice I left the lower indexes blank everywhere, because sometimes they stay exactly the same as the original series, but sometimes they change. You can think it through, or you can expand a little bit. When n is 1, the first term and second term are here. So if we take the derivative, then the first term should be 2 times x minus 3 to the 1 over 3. And you can check to see if this first term, the derivative of this first term, is obtained when n is equal to 1. So if n is equal to 1, we have a positive 2 x minus 3 to the 1 over 1 times 3. It works. So when it doesn't work is when the first term generated is sometimes a constant. And then if you take the derivative of the constant, the first term would be 0, in which case you wouldn't need to start when n is 1. You might start when n is 2 to get the first non-zero term. But in this case, our first term still exists when n is equal to 1. And when we go and take another derivative, this first term is going to be 2/3. And when n is equal to 1, we should get 2/3 because this isn't a constant, so there will be a first term when you take the derivative to get the second derivative. When n is equal to 1, we have a positive 2, and this is raised to the 0 power, so it's just 2 over 3. Bingo. How about for the antiderivative? Well, let's take the antiderivative of this first term when n is 1. We should get up the power, using the power rule, x minus 3 to the third. But we need 3 there, so we need to put a factor of 3 in the bottom. So 3 times x minus 3 squared over 9. 3 over 9 is a third, so we're left with just 3 in the bottom. This checks. All right, so all of the indexes stay the same. They start at 1. Well, there's only one thing missing from this answer to number 45. Do you see it? That's right, the antiderivative needs to have a constant. And now this problem is complete. I hope this little discussion helped.